Hello everyone, I am Dr. Padmasree Lam, Professor in Department of ECE at VNR VJEC. In previous video, we have covered types of samplers, types of mixers, feedback topologies, and block diagram of feedback amplifiers. In this video, we will learn about analysis of voltage series feedback amplifier. Contents covered are derivation for voltage gain with feedback, derivation for input resistance with feedback, derivation for output resistance with feedback of voltage series feedback amplifier. So this is the block diagram of voltage series feedback amplifier. By seeing the name of the feedback amplifier, we can easily understand that which type of sampler is used in this amplifier, which type of mixer is used in this amplifier. First term represents a sampler. Second term represents mixer. That means in voltage series feedback, voltage sampler is used at the output terminals of the basic amplifier. This is the connection for voltage sampler. Series mixer is used at the input terminals of the basic amplifier. This is the connection for series mixer. In the case of series mixer, source must be voltage source. So after identifying the type of the sampler, type of the mixer in the given amplifier, so now you observe the signal present at the input terminals of the feedback network. These two are input terminals of the feedback network that is connected in shunt to output terminals of the basic amplifier. Then the signal present at the input terminals of the feedback network is V0. And output terminals of the feedback network is connected in series to input terminals of the basic amplifier. Then what is the signal present at the output terminals of the feedback network? That is VF, voltage signal. So after identifying input and output of feedback network, you can write down feedback factor or gain of the feedback network. Beta is ratio of output of feedback network to that of input of feedback network. Therefore, beta is equals to VF by V0. So AV is voltage gain of the amplifier. AV is voltage gain of the amplifier without feedback. Amplifier without feedback. What is the basic amplifier in voltage series feedback amplifier? Voltage amplifier. So this is basic amplifier. AV is voltage gain of the basic amplifier without feedback, and feedback factor beta is VF by V0. Feedback signal VF is proportional to output voltage. In voltage series feedback circuit, type of the sampler is voltage sampler and type of mixer is a series mixer. In voltage series feedback circuit, a fraction of the output voltage is applied in series to input voltage through the feedback circuit. This is the feedback circuit. So next we will see about derivation for voltage gain with feedback. So basic amplifier used in this feedback amplifier is voltage amplifier. The circuit represented in these dotted lines is equivalent circuit of voltage amplifier. So voltage amplifier can be represented with Thevenin equivalent circuit at the output terminals, and input terminals of the voltage amplifier can be represented with RI. What is RI? RI is Ri is input resistance without feedback. AV is voltage gain of the amplifier. So input terminals of the voltage amplifier can be represented with Ri, where Ri is input resistance without feedback, and output terminals of the voltage amplifier can be represented with Thevenin equivalent circuit. What is Thevenin equivalent circuit? Voltage source in series with R0. Magnitude of that voltage source is AV into Vi, and output resistance is R0. Output resistance is R0. So the circuit represented in these dotted lines is equivalent circuit of the voltage amplifier, and then connect load resistance between the output terminals RL, and coming to input terminals. So output of the feedback network is VF. That output of the feedback network is VF, that can be represented with some voltage, that is VF, and then connect VS. Okay, so this is the complete equivalent circuit of voltage series feedback amplifier. So Ri is input resistance without feedback. Now we will see the derivation for voltage gain with feedback. What is the output of the feedback amplifier? V0. What is the input of feedback amplifier? Vs. Therefore, voltage gain AVF is equals to ratio of output of feedback amplifier to that of input. That means V0 by Vs. Okay. So voltage gain without feedback. That means voltage gain of the voltage amplifier, that is AV is equals to V0 by Vi. Okay. So from this expression, what did you get? V0 is equals to AV into Vi. That is equation 1. Apply KVL in the input loop of the circuit. By applying KVL in the input loop of the circuit, observe the polarities. Polarity of Vs is like this. And how many voltages in the input loop? One is Vs, and another one is Vi, and third one is Vf. So observe the polarities of all voltages and then apply KVL in the input loop. So what did you get? Vs, by applying KVL in clockwise direction, apply KVL in clockwise direction. This is from negative to positive. Negative to positive, you can be considered as positive. And to apply KVL in clockwise direction, Vi polarity is traversing from positive to negative. Then that is minus Vi, and Vf polarity is also from positive to negative in clockwise direction. That is minus Vf is equals to 0. So from this, what did you get? Vi is equals to Vs minus Vf. But what is Vf? Vf is beta V0. Substitute Vf is equals to beta V0. Then Vi becomes to Vs minus beta V0. Okay. So what is equation 1? Equation 1 is V0 is equals to AV into Vi. Substitute this Vi in equation 1. Then the above expression, equation 1 becomes V0 is equals to AV into Vs minus beta V0. So to rearrange the terms, then you will get AV into Vs minus beta AV into V0. By rearranging the terms, you will get V0 into 1 plus beta AV is equals to AV into Vs. So what is the equation for voltage gain with feedback? AVF is equals to V0 by Vs. So from this expression, what did you get? V0 by Vs is equals to AV by 1 plus beta AV. So therefore, voltage gain with feedback is AVF is equals to AV by 1 plus beta AV. So what is AVF? Voltage gain with feedback. What is AV? Voltage gain without feedback. Okay. And 1 plus beta AV is desensitivity. From this expression, you can easily conclude that voltage gain of voltage series feedback amplifier decreases by the factor of desensitivity than without feedback. So that means AVF is always less than AV. So that is the final conclusion. And AVF is equals to AV by 1 plus beta AV. So from this derivation, you can easily understand that voltage gain of feedback amplifier decreases by the factor of 1 plus beta AV than without feedback. Next, we will see the derivation for input resistance of voltage series feedback amplifier. So already we have learned about that, how to draw the equivalent circuit, and now we have to remember the terms. What is Ri? Ri is input resistance without feedback, and now we have to find out input resistance with feedback. So input resistance with feedback is RIF. What is the input of the feedback amplifier? Input voltage of the feedback amplifier is Vs, and input current of the feedback amplifier is II. Therefore, RIF is ratio of Vs to II. Then apply K. Now we have to find out expression for RIF in terms of Ri. What is Ri? Input resistance without feedback. So what is the expression for input resistance without feedback? Ri is equals to Vi by Ii. So remember this point. Derive the expression for RIF in terms of Ri. So now you can apply KVL in the input loop. You will get Vs is equals to Vi plus Vf. But Vf is equals to beta V0. By substituting Vf in the above expression, so Vs is equals to Vi plus beta V0. Okay. But what is AV? AV is voltage gain without feedback, that is ratio of output of the voltage amplifier to that of input of voltage amplifier. V0 is output voltage of the voltage amplifier. Vi is input voltage of the voltage amplifier. So from this expression, what did you get? V0 is equals to AV into Vi. Substitute V0 in the expression of Vs. Then what did you get? Vi plus beta AV into Vi. So and then take Vi as common, Vi into 1 plus beta AV. Okay. So already we have seen the expression for input resistance with feedback. RIF is equals to Vs by Ii. Substitute Vs in this expression. That is equals to Vi into 1 plus beta AV divided by Ii. So what is the ratio of Vi to Ii? Vi to Ii is input resistance without feedback. So then substitute instead of Vi by Ii as Ri. Then finally you will get RIF is equals to Ri into 1 plus beta AV. So this is the expression for input resistance with feedback. So what did you understand by seeing this expression? Input resistance of voltage series feedback amplifier increases by the factor of 1 plus beta AV than without feedback. What is 1 plus beta AV? Desensitivity. So that means RIF increases by desensitivity than without feedback. Okay. So in voltage series feedback amplifier, input resistance increases. What is the reason for that? We are going to use series mixer in the input terminals of the basic amplifier. That means output terminals of the feedback network is connected in series to signal source. That's why input resistance increases. So output resistance of voltage series feedback amplifier. To determine output resistance of the feedback amplifier, so remember this point, R0F, derive the expression for R0F in terms of R0. What is R0F? Output resistance with feedback. R0F is output resistance with feedback. Okay. What is R0? Output resistance of the voltage amplifier. That means without feedback. R0 is output resistance without feedback. So you can find out output resistance similar to Thevenin resistance. How can you find out Thevenin resistance? Disconnect the load resistance from the circuit. And set the input source to 0. What is the input source in voltage series feedback amplifier? Vs. What is the meaning of Vs is 0? Voltage source can be replaced with short circuit. If Vs is 0 means that source terminals can be replaced with a short circuit. Okay. So after disconnecting the load resistance from the output terminals, apply test voltage. V is the test voltage. V is test voltage. Apply the test voltage V between the output terminals, and current flowing through the output terminals is I. I is the test current. I is test current. Okay. So now the equivalent circuit of voltage series feedback amplifier has been modified like this to determine the output resistance. So what is Vf? Vf is equals to beta V naught. But we are applying test voltage between the output terminals. So beta V naught is equals to beta Vf is equals to beta V. So feedback voltage Vf is equals to beta V. By setting the voltage source to 0, then what is the expression for Vi? Vi is equals to minus Vf. But Vf is equals to beta V. Then Vi is minus beta V. What is the expression for output resistance with feedback? R0F is ratio of test voltage to test current. That means ratio of V to I when Vs is equals to 0. By applying KVL in the output loop, so see the polarities of Vi, see the polarities of test voltage. This is from minus to plus. So then V is equals to, if the current is flowing in this direction, polarity of voltage drop is, this is positive, this is negative. Okay. So current flowing through R0 is I, voltage drop across R0 is I into R0, and magnitude of this voltage source is AV into Vi. So by applying KVL in anti-clockwise direction, you will get V is equals to I into R0 plus AV into Vi. Okay. From this expression, what did you get? I is equals to V minus AV into Vi divided by R0. Okay. So suppose This is VI is equals to minus beta EV. Substitute, this is equation 3. Substitute VI is equals to minus beta V in equation 3. Then the above expression becomes I is equals to V into 1 plus beta AV by R naught. So what is the expression for output resistance with feedback? R naught F is equals to V by I, that is equals to R naught by 1 plus beta AV. So what did you understand by seeing this expression? Output resistance of voltage series feedback amplifier decreases by the factor of 1 plus beta AV than without feedback, because R naught is output resistance without feedback and R naught F is less than R naught. What is the reason for that? In the case of output terminals of the amplifier, where we are using voltage sampler, that means input terminals of the feedback network is connected in shunt to input terminals of the basic amplifier. Therefore, output resistance decreases by the factor of 1 plus beta AV. So R naught F is output resistance of the voltage series feedback amplifier excluding load resistance. Now R naught F dash is the circuit present between these two terminals can be replaced with R naught F. What is R naught F? Output resistance with feedback. And R naught F is output resistance excluding load resistance, because we have disconnected load resistance to find the R naught F. So then output resistance including load resistance is R naught F dash. R naught F dash is R naught F in parallel to RL. Okay, I think we have clearly understand that output resistance excluding RL is R naught F, that is R naught by 1 plus beta AV. R naught F is less than R naught by the factor of desensitivity. Desensitivity is 1 plus beta AV, and output resistance including load resistance is R naught F dash, that is equals to R naught F in parallel to RL. So in voltage series feedback amplifier, feedback circuit is connected in series with the input terminals of the basic amplifier. Therefore, input resistance increases. And feedback circuit is connected in shunt to output terminals of the basic amplifier. Therefore, output resistance decreases. So now we will see the conclusions of voltage series feedback amplifier. Voltage gain with feedback is AVF is equals to AV by 1 plus beta AV. Voltage gain with feedback decreases by the factor of 1 plus beta AV than without feedback. And input resistance of voltage series feedback amplifier is RIF is equals to RI into 1 plus beta AV. So then input resistance of feedback amplifier increases because of the series connection between the input terminals. And output resistance of the feedback amplifier decreases because of shunt connection between the output terminals of the basic amplifier. So I think now we have clearly understand that derivation for voltage gain with feedback, input resistance with feedback, output resistance with feedback of voltage series feedback amplifier. References for preparation of this video are Integrated Electronics by Millman and Akias, Electronic Devices and Circuits Theory by Boysted, Electronic Circuit Analysis by Shalivahana. In the next video, we will see the analysis of voltage shunt feedback amplifier. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.